This is the pre-lab for Unit 2, the pendulum experiment, and the force table. I've done that for years and years, and I still have to remind myself which is the other lab. So question 1, I'm just going to cough here just for a moment. I'm going to turn the mic off. All right, better. So question 1, you, the student, will attend a lab intensive. I don't know why this keeps scrolling down. So one of the labs is the pendulum, the objectives. So look these up. That's what the pre-labs are for. Look at the lab manual so that you're prepared for the lab intensive. Confirm the first order approximation for the period of a simple pendulum. You will see that in the lab when you actually read through it, what that means. And so it's the first 3 objectives that you will see there. In the theory part, you will find that the equation of motion, Newton's second law, sum of the forces equals mass times acceleration applied to a pendulum, is tension plus weight plus air resistance equals mass times acceleration. That only the tangential component x is of interest because that's the direction of the pendulum's motion. The angles will be held very small, so it will really be in the horizontal. Solving for g, the algebra yields this equation, and that's what you have to check, where g is at this point not 982 centimeters per second squared, but it's the unknown. And of course, as you're determining it throughout the experiment, you should be getting pretty close to the expected 982 centimeters per second squared. Right, question 4. Pendulum lab procedures. There are a number of things here that students have done wrong in the past, so I want to point these out. For example, here, let the pendulum swing less than 10 degrees. Measure times correctly. Start the count at 0 as you let it go, and so on. So the length of a pendulum is measured between the suspension point and the approximate center of mass of the swinging object. The length of the pendulum is not measured between the suspension point at the bottom or the top of the swinging object. Benchmark lengths mean that a successful experiment doesn't depend on adhering to those values that I give, but that however the pendulum is strung up, that's the length that you use. And you can read through these here. These should be in the correct order, these statements. You will find an example, and these are the ones that are included. These others here may actually be correct statements. They're just not in the lab manual. For the force table, these are the objectives. Confirm Newton's second law by measuring force on a force table, and the other 2 here. In the theory part, there's Newton's second law. Sum of the forces equals the net force, and W here stands for weight, so all the forces that are acting here are the weights actually. For the procedures, contrast between scalars and vectors, and name some examples. Scalars are such as mass and temperature. Vectors as such as velocity and force have a magnitude and a direction. You have to suspend a certain amount of mass over each pulley. Why do you need to compute the weight in newtons of each mass? Well, the mass is a scalar, but the force itself is a weight. And I have to turn the mic off again. And then you can read through the others yourself and look at the lab manual. Again, that's the idea. These should be in the correct order. Then this one here, there are a couple of examples. In the lab manual, you will find these as examples, and then in the video that's posted, you will find the other ones in the other color here. And these 3 are not listed. And then question 10, that's kind of like an open answer. You have to look up an example yourself for a vector problem. And that's the pre-lap for the Unit 2 labs.